Curtain number 9 was the pinnacle of the brothers' development of the flying wing. And the prototype achieved a speed of something like 500 miles an hour.
The impossible discoveries expanded in the quiet, climate-controlled halls of a modern laboratory. A team of scientists fed a centuries-old map into a machine that might as well have been science fiction. This wasn't just any computer. It was a quantum-enhanced artificial intelligence system capable of analyzing patterns invisible to the human eye, comparing them to vast archives of historical and geographical data, and detecting anomalies that defy conventional understanding. And what it uncovered on a 14th-century medieval map was nothing short of astonishing. The map itself, a carefully preserved piece of calfskin vellum, had survived 6 centuries of human handling, wars, neglect, and shifting political boundaries. To the casual observer, it looked like any other medieval chart: intricate lines of coastlines, decorative illustrations of ships and sea monsters, and faded Latin inscriptions along the margins. For hundreds of years, historians had catalogued it, studied it, and dismissed many of its more curious features as artistic embellishment or simple mistakes by the mapmaker. Yet, the quantum AI revealed secrets that had been hiding in plain sight for centuries. Coastlines that no longer exist today, islands that vanished beneath the waves, and a precision that modern scholars still struggle to comprehend. It started with the coast of Wales. When the AI scanned the map using ultraviolet and multispectral imaging, it detected faint lines running along the coastline that were invisible to the human eye. These weren't random scratches or smudges. They were precise, deliberate, and remarkably detailed. The AI's analysis suggested that the coastlines extended roughly 8 meters further into the sea than they do today. That's not a trivial difference. That's land that existed in the 1300s and is now completely submerged, a direct testament to centuries of coastal erosion or rising sea levels. But it didn't stop there. The AI detected 2 small islands off the Welsh coast, islands that appear on no modern chart, no satellite map, and no historical record. When marine geologists compared the positions of these ghost islands with modern bathymetric scans, the underwater equivalent of topographical maps, they found something extraordinary. Beneath the waves, the island's former landmass corresponded perfectly with underwater ridges in Cardigan Bay. These ridges, once likely above water, could have supported small settlements or been part of navigable landscapes during the 14th century. For generations, Welsh legends had told of Cantor Gwyliad, a fabled land swallowed by the sea. Folklore, long dismissed as myth, now had a footprint in hard data. The mapmaker who drew these coastlines wasn't imagining them. He was recording geography that time had erased. The precision of these discoveries is almost unfathomable. Consider the historical context. This map was created centuries before telescopes, airplanes, or satellites existed. The mapmaker could never have flown over these lands to record them from above, and yet the AI's analysis shows the shapes and contours of coastlines with incredible accuracy. The lines are smooth, coherent, and measured, not whimsical. They suggest that the mapmaker possessed knowledge far beyond what historians previously credited to medieval European cartographers. Did he have access to records of long, forgotten voyages? Did he rely on oral accounts that survived across generations? Or was he simply extraordinarily skilled at compiling and correcting observational data? Yet the map's most intriguing features were at its edges, particularly the western margin. Here, beyond the familiar shapes of Europe, North Africa, and even the Canary Islands, the map revealed a faint, fragmentary coastline that should not have been known to any European at the time. To medieval eyes, the Atlantic was a vast, uncharted expanse. Columbus and other explorers would not sail these waters for another century. And yet, the AI detected deliberate lines that resembled a landmass, a coastline that appears to stretch far into the ocean, incomplete but unmistakably intentional. For centuries, historians had dismissed this portion as an ink smudge or decorative flourish. The quantum AI proved otherwise. It was a deliberate outline, carefully drawn, suggesting knowledge of lands beyond the accepted boundaries of the known world. Researchers have proposed three possible explanations for this mysterious Western fragment. The first is rooted in medieval imagination. It could represent one of the mythical Atlantic islands that frequently appeared in sailor lore. Islands like Hy Brasil or Antilia were legendary in the Atlantic and appeared on countless maps long before Columbus sailed. They weren't necessarily real, but they reflected stories, sightings, or temporary islands created by volcanic activity or shifting sands. The mapmaker could have been compiling these stories into a coherent visual record. The second possibility is even more intriguing. Perhaps the map preserves fragments of Viking knowledge. Norse explorers reached North America in the 11th century, establishing settlements in regions they called Vinland, Markland, and Helluland. Could stories of these western lands have filtered south into the Mediterranean, carried along trade routes, or through travelers who shared tales with European mapmakers? It's plausible. The AI analysis shows that certain features in the western margin align remarkably well with descriptions from the Viking sagas, suggesting that some form of information traveled across continents centuries before the age of exploration officially began. The third explanation, more mundane but still significant, is that the fragment is a copying error. Medieval maps were often reproduced by hand, and mistakes were common. A misaligned coastline or duplicated feature could have crept into the map during one of these reproductions. Yet, even if this were the case, it raises questions about why such errors would so accurately correspond with underwater topography discovered centuries later. The alignment of the ghost islands and coastlines with modern geophysical data is so precise that chance seems unlikely. Beyond these broad strokes, the quantum AI uncovered a network of hidden details embedded in the map itself. Using multispectral imaging, the AI detected erased draft lines beneath the visible ink, lines that reveal careful calculations and pre-planning. There were subtle compass grids, geometric patterns that extended across the map, and indications of an early system of surveying. These patterns weren't immediately visible to medieval eyes, but the AI brought them into focus. It appeared that the mapmaker was accounting for curvature, adjusting distances, and correcting errors in a way that echoes methods developed centuries later. The AI also revealed faint annotations along the margins, tiny Latin inscriptions that had faded over time. At first glance, these notes might seem trivial, but the AI reconstructed them and showed something far more profound: a proto-coordinate system using angles and distances to indicate precise locations. This wasn't latitude and longitude as we know it, but it was a structured attempt to measure and map the world systematically. The mapmaker was developing his own mathematical language for geography, experimenting with methods to record positions and distances in a consistent, repeatable manner. Even more remarkable were the cross-cultural connections that the AI identified. The system compared this European map with Islamic maps from North Africa and found similar phantom islands in the Atlantic. Independent charting in Morocco and Egypt during the same period had produced strikingly similar features, despite the apparent lack of direct contact between these civilizations. The AI also examined Chinese maritime charts from the Yuan dynasty and detected anomalies that corresponded with portions of the European map. Additionally, Viking descriptions of North America showed remarkable alignment with these same Western fragments. These correlations suggest a hidden web of shared knowledge, a transfer of information across continents and cultures that defies our understanding of medieval isolation. The map was not merely a navigational tool, it was a multi-dimensional record of observation, experimentation, and empirical reasoning. It preserved environmental changes, recorded coastlines and islands long since lost, and encoded information that only modern quantum AI could fully decode. These discoveries challenge the long-held perception of the Middle Ages as a period of intellectual stagnation. Medieval mariners were not blindly following coastlines, they were analyzing, recording, and refining data over generations. They practiced a form of empirical science long before formal statistical methods or standardized surveying techniques existed. And yet, the most striking part of all is that this knowledge was almost lost entirely. The map survived, but its deeper secrets lay hidden until now, locked away in faded ink and invisible lines. Without quantum AI and multispectral imaging, historians would never have grasped the extraordinary precision and sophistication embedded in a single piece of vellum. It is a testament to human ingenuity, curiosity, and persistence. A record of how our ancestors sought to understand the world with the tools they had, and how some of that knowledge, lost for centuries, can still astonish us today. The implications of these discoveries are profound. First, they remind us that history is not static. Facts and narratives can change when we develop the tools to see more clearly, to analyze in ways that were previously impossible. Second, they challenge assumptions about medieval societies, showing that practical knowledge, data collection, and systematic observation existed far earlier than previously thought. Third, they open the possibility that other maps, documents, and artifacts from this era may contain equally extraordinary hidden knowledge, waiting for the right combination of technology and curiosity to unlock it. This one map, hidden for centuries, reshapes the way we view the Middle Ages. It tells a story of mariners, explorers, and mapmakers who were more sophisticated, more observant, and more connected than we've given them credit for. They collected data across generations, shared insights across civilizations, and encoded knowledge in ways that would remain invisible until the advent of modern technology. The land, the islands, the lines, they are more than cartographic features. They are evidence of a human mind reaching beyond its time, experimenting with measurement, geometry, and observation in ways that echo the foundations of modern science. In the end, the quantum AI didn't just uncover lost coastlines. It revealed a lost mindset, a world of methodical observation, experimentation, and empirical reasoning that existed in an era often dismissed as intellectually limited. It showed that the past is not fixed, that knowledge can survive centuries hidden in plain sight, and that the curiosity and ingenuity of our ancestors continue to inspire discoveries today. From the faint lines along the Welsh coast to the mysterious Western Atlantic fragment, this 14th-century map is no longer just a relic. It is a bridge between centuries, connecting human curiosity, empirical experimentation, and technological discovery. And as modern scientists continue to decode it, the map reminds us that history is never fully written. It is waiting, patiently, for the next observer to uncover its secrets. Hidden methods and quantum revelations. The first point revealed astonishing geographic discoveries, coastlines lost to time, ghost islands beneath the waves, and a mysterious Western Atlantic outline that shouldn't have existed on any 14th-century map. But that was only the beginning. What made these revelations possible wasn't just the map itself. It was the extraordinary methods hidden in plain sight, waiting for the right technology to reveal them. To unlock the secrets, researchers turned to technology that the mapmaker could never have imagined. The medieval cartographer worked with ink, quill, and vellum, guided by compass, ruler, and careful observation. Today, scientists were armed with quantum, enhanced artificial intelligence, multispectral imaging, and gigabytes of spectral data. Quantum computing allowed the AI to process vast patterns and correlations simultaneously, something classical computers struggle to do even with modern supercomputing. For the first time, the faintest traces of erased lines, hidden notations, and subtle corrections could be revealed in detail unimaginable even to expert historians. When the team first scanned the map using ultraviolet, infrared, and multispectral wavelengths, the results were breathtaking. Beneath the visible ink, hidden layers emerged: draft lines, tiny scratches, and adjustments meticulously made by the mapmaker before committing to the final layout. These ghost lines formed coherent patterns rather than random scrawls. They suggested careful calculation and iteration, a process of experimentation and refinement. This wasn't art alone, it was methodical science. The cartographer, though working centuries before Galileo or Newton, was already testing hypotheses, correcting errors, and improving his maps with each attempt. Among the most remarkable revelations were hidden geometric structures that appeared across the entire map. Subtle grids, almost imperceptible to the naked eye, emerged when the AI processed certain wavelengths. These grids were not merely aesthetic, they were functional. They indicated a primitive but sophisticated system of calibration, likely intended to correct for distortions caused by representing a spherical Earth on a flat surface. Modern cartographers understand that projecting a curved surface onto a plane introduces distortion, but here was a medieval mind compensating for it intuitively. The mapmaker was essentially practicing an early form of geodesy, centuries before the mathematics of map projections would be formalized. The margins of the map, previously dismissed as decorative flourishes, held some of the most profound discoveries. Small doodles and seemingly random scribbles, when digitally enhanced, revealed precise geometric relationships with the coastlines they accompanied. In some cases, the shapes aligned perfectly with hidden compass grids. These marginalia were not idle decorations, they were part of a mathematical system, a rudimentary coordinate system that allowed the cartographer to position geographic features relative to one another. It's as if the mapmaker had invented a form of scientific notation for geography, a language of angles, distances, and bearings long before such ideas were formalized. Even textual notes in Latin, faded almost beyond recognition, were reconstructed by the AI. What emerged was a set of instructions, measurements, and angles. Though not using degrees in the modern sense, the notation system indicated a structured approach to recording locations. Lines measured from fixed points, numerical values corresponding to distances along the coastline, and repeated calculations suggested that the mapmaker was cross-referencing observations from multiple sources. These were not rough estimates. They were iterative approximations refined with each new piece of data, resembling the process of data averaging centuries before formal statistics existed. One particularly striking feature was the AI's detection of overlapping corrections along coastlines. In some areas, faint, almost invisible ink indicated that the original line had been erased and redrawn, often multiple times. This suggested that the mapmaker had access to different accounts of the same coastline and carefully adjusted the drawings to reconcile them. The result is remarkable. Despite lacking modern tools, the mapmaker achieved levels of accuracy comparable to observations confirmed by contemporary satellite imaging. This was not mere luck. It was a systematic method of observation, calculation, and verification, executed with nothing more than simple instruments and a keen mind. The quantum AI also uncovered an entirely hidden network of relationships connecting different parts of the map. Certain islands, coastlines, and peninsulas, when measured with the AI's enhanced tools, were spaced according to proportional relationships, reflecting an understanding of scale and relative distances that would be astonishing for the period. Even decorative illustrations, once dismissed as fantasy, were aligned with these measurements. A dragon in the corner, for example, was not merely artistic, it served as a marker, a point of reference in the cartographer's geometric system. The AI reconstructed these subtle patterns, revealing an intricate latticework of logic woven into the map's design. Beyond the technical brilliance of these hidden methods, the AI revealed an experimental mindset. The cartographer was testing hypotheses, checking measurements, and iteratively refining his work. In one corner of the map, Erased lines indicated multiple attempts to chart a particular bay with precise curvature. Marginal notes referenced measurements taken at different times, possibly from different voyages or witnesses. This was empirical science in action: observation, experimentation, correction, and refinement. It challenges the assumption that medieval societies were incapable of systematic study. As researchers delved deeper, they found patterns in the map that suggested early attempts at universal mapping standards. Certain coastlines were marked with symbols corresponding to compass directions and estimated distances, while other regions included notes referencing angles from fixed points. This system wasn't standardized, and yet it demonstrated that medieval mapmakers were experimenting with consistent methods for recording information across multiple voyages. They were laying the foundations of what we now call cartographic science. The AI's analysis also revealed that the mapmaker had likely compiled information from a variety of sources. Some features matched local knowledge, collected from fishermen and merchants. Others corresponded to voyages undertaken by explorers across the Atlantic or along the North African coast. The AI identified correlations between coastlines in Europe, North Africa, and even beyond, revealing a network of shared maritime knowledge previously unrecognized. Knowledge that was likely transmitted orally or via fragmented documents had been distilled into a coherent, empirical system. One of the most mind-bending discoveries came when the AI reconstructed subtle overlays of the map with other contemporaneous charts from Europe, North Africa, and East Asia. What emerged was a striking pattern despite minimal direct contact. Maps from different civilizations contained remarkably similar features. Phantom islands in the Atlantic appeared on Moroccan charts, Chinese Yuan dynasty maritime maps, and even scattered European sources. These independent confirmations suggest that knowledge of distant lands and oceanic features was traveling far more effectively than historians previously believed. The mapmakers' hidden methods were not just local. They were part of a global network of empirical observation. The implications of these discoveries are staggering. The medieval mapmaker wasn't just a passive recorder of information. He was an innovator, a proto-scientist experimenting with data collection, empirical validation, and geometric correction. His tools were simple, yet his methods were sophisticated, resembling modern scientific approaches in principle, if not in notation. Every erased line, every subtle marginal note, every geometric doodle was a testament to centuries of accumulated observation, experimentation, and refinement. The quantum AI also highlighted the map's temporal significance. The coastlines, islands, and features recorded had changed over the centuries. Land that existed in the 1300s was now submerged. Some islands, once prominent, had disappeared beneath the waves. By analyzing these changes, the AI provided insight into historical environmental shifts from erosion to sea level rise. The map wasn't just a historical artifact. It was a record of dynamic changes in geography over time, a medieval snapshot of a world in flux. Even the smallest features told a story. Faint sketches of river mouths, harbors, and tidal patterns indicated a practical understanding of maritime navigation, suggesting that the mapmaker was designing the chart not just for aesthetic or theoretical purposes, but as a functional guide for sailors. Combined with the hidden geometric grids and proto-coordinate system, the map demonstrates an unprecedented integration of observation, mathematics, and practical application, a combination that modern historians often attribute only to later centuries. Ultimately, the quantum AI transformed our understanding of this map. What had once been dismissed as a simple medieval chart became a multi-layered historical document, revealing the hidden methods of an empirically minded, globally connected, and extraordinarily precise cartographer. The AI illuminated not only the geographic content, but also the process behind it: careful observation, iterative correction, cross-referencing, empirical reasoning, and experimental notation. This was a scientific approach centuries ahead of its time, and yet the AI also raised questions that remain unanswered. How did this mapmaker achieve such precision without advanced instruments? How much knowledge was transmitted across cultures and centuries, influencing his work? What other hidden features might exist, waiting to be revealed by technology not yet invented? Each discovery opens new doors to the past, suggesting that medieval societies were far more sophisticated, observant, and interconnected than conventional histories have acknowledged. The hidden methods revealed by the quantum AI tell a profound story. Human curiosity and ingenuity transcend time. They remind us that science, observation, and innovation are not bound by centuries but by the human mind's desire to understand. The medieval mapmaker, long overlooked, was a pioneer, quietly recording the world with a precision and foresight that modern technology is only now capable of appreciating. He left behind a legacy of methods, processes, and insights that challenge our assumptions about history, knowledge, and the human capacity for discovery. This revelation forces us to rethink the Middle Ages entirely. No longer can we see it as a time of intellectual stagnation. Instead, it was a period in which practical knowledge, experimentation, and cross-cultural communication flourished in ways we are only beginning to recognize. The map, once a static artifact, becomes a living document, a record of human observation, innovation, and the relentless quest to understand the world. It bridges the centuries, connecting the medieval mind to the capabilities of quantum, enhanced AI, and reminds us that the pursuit of knowledge is a timeless human endeavor. Cross-cultural connections and hidden inscriptions. The medieval map's hidden methods and astonishing precision were already rewriting what we thought we knew about cartography in the 14th century. But the story becomes even more extraordinary when we widen the lens. This wasn't just a local or European phenomenon. The mapmaker's knowledge hints at a far broader network of information, one that transcended borders, cultures, and even continents. By comparing this chart with contemporaneous maps from distant civilizations, researchers began to uncover connections that challenge conventional history. To understand the global significance of the map, the team employed the quantum AI to cross-analyze charts from Europe, North Africa, the Middle East, East Asia, and even fragments of Norse exploration accounts. Using sophisticated pattern recognition algorithms, the AI could overlay maps digitally, align coastlines, and compare topographic features across centuries and cultures. The results were shocking. Features that appeared on this single European chart appeared independently on Moroccan, Egyptian, and Chinese maps, often with remarkable alignment despite the lack of direct contact between these civilizations.